Compound from the following that will not produce precipitate on reaction with AgNO3 is. First one, in this compound, when this carbon-bromine bond breaks, what happens? There is a positive charge on this carbon, and this positive charge is delocalized on the ring because of the presence of these pi electrons. So this carbocation which is formed during this reaction is stabilized by delocalization of the positive charge. Next, the second one. In the second one, if this carbon-bromine bond breaks, the positive ion formed is highly unstable. It is not stable, it is unstable. Third one, in this case, since bromine is bonded to carbon atom which is bonded to the benzene ring. So this is benzylic carbon. Now here if carbon-bromine bond breaks, then there is positive charge on this carbon, and this positive charge gets delocalized on the benzene ring, because of which this carbocation is also highly stable. Now fourth one, when this carbon-bromine bond breaks, now this is allylic carbon. So this allylic carbon gets a positive charge, and this positive charge is delocalized on the adjacent carbon atom, because the adjacent carbon atoms, they have pi electron, and these pi electrons help in the delocalization of positive charge, making this carbocation stable. So out of 1, 2, 3, 4, the carbocation formed in the option 2, this carbocation formed in this case is unstable, and therefore this compound will not produce precipitate on reaction with AgNO3. So correct answer is option 2. Hello students. Next question. Identify the correct order of reactivity for the following pairs towards the respective mechanism. Now option A, the mechanism is SN2 mechanism, and these are the two alkyl halides. Let this be alkyl halide 1 and this is alkyl halide 2. Now it is given that alkyl halide 1 is more reactive towards SN2 mechanism, or it undergoes nucleophilic substitution by SN2 mechanism more readily than the alkyl halide number 2. Now if we see this alkyl halide number 1, then the carbon which is bonded to the halogen atom, it is the primary carbon atom, and in alkyl halide 2 the carbon bonded to the halogen atom is tertiary carbon atom. Now primary alkyl halide undergoes nucleophilic substitution by SN2 mechanism more readily than the tertiary. The reason being, in primary alkyl halide the steric hindrance near the carbon atom which undergoes the nucleophilic substitution is less in comparison to the tertiary alkyl halide. Now this carbon, in case of tertiary alkyl halide, the carbon which undergoes nucleophilic substitution, it is surrounded by 3 methyl groups. So there is a lot of steric hindrance, because of which it does not undergo nucleophilic substitution by SN2 mechanism. So the order shown in option A is correct. Now in option B, again here it is about substitution nucleophilic unimolecular, means mechanism followed is SN1. So if this carbon bromine bond breaks, the carbocation which is formed here, the positive charge gets delocalized in the benzene ring. These pi electrons will come here and the positive charge will get delocalized on the benzene ring. But in this alkyl halide, if this carbon bromine bond breaks, the positive charge does not get delocalized on the benzene ring. The reason being, in case of alkyl halide number 1, the positively charged carbon atom is directly bonded to the benzene ring, so the positive charge gets delocalized in the benzene ring. But in case of alkyl halide 2, the positively charged carbon is not directly bonded to benzene ring, so no delocalization of positive charge takes place. So the compound 1 undergoes nucleophilic substitution by SN1 mechanism more readily than the compound 2. The order of reactivity shown in option B is also correct. Now C, chlorobenzene. In chlorobenzene, chlorine atom is bonded to the benzene ring and chlorine has lone pair of electrons. These lone pair of electrons get delocalized on the benzene ring, creating a negative charge density at ortho and para positions, because of which ortho and para positions become rich in electron, and they easily undergo electrophilic substitution reaction. This chlorobenzene is reactive towards electrophilic substitution reaction, but if there is a nitro group present at the para position, now NO2 group being electron withdrawing group, reactivity of para-nitrochlorobenzene towards electrophilic substitution decreases because this NO2 group attracts the electron towards itself, because of which the electron density in the benzene ring decreases. So the order of reactivity shown in option C is also correct. Now option D. In option D, this is bromobenzene, and here there is a NO2 group present at the para position. Again, this bromobenzene is less reactive towards nucleophilic substitution reaction in comparison to the one containing NO2 at the para position, because nucleophilic substitution means nucleus seeking group. A group which is rich in electron will attack the benzene ring where the electron density is low. Now since NO2 group is electron withdrawing group, it decreases the electron density in the benzene ring and makes it more reactive towards nucleophilic substitution. So the order of reactivity shown in option D is also correct. Now for SN1 and SN2 we can also write, for SN2 reaction the reactivity is inversely proportional to steric hindrance, and for SN1 reaction the reactivity is directly proportional to the stability of the carbocation. Now since the order of reactivity shown in all the options A, B, C and D are correct, so here the correct option is option 4. Next question. Choose the halogen which is most reactive towards SN1 reaction in the given compounds. Now option A. There are two halogens marked as A and B. Bromine marked as A and B. We have to find out which one of this bromine is most reactive towards SN1. Now SN1 reaction proceeds by the formation of carbocation. For example, a compound like this, suppose CH3, H, CH3 and here halogen. This carbon halogen bond breaks and it results in the carbocation intermediate and the halide ion. So this is the intermediate formed. Now the more is the stability of the carbocation formed, more will be the reactivity of this given compound towards SN1 reaction. Out of these two bromine atoms, if this bromine leaves as bromide ion, then the carbocation which is formed will be stabilized by the delocalization of the positive charge on the benzene ring. What will happen? These pi electrons will come here and this positive charge will get delocalized on the benzene ring. So carbocation formed by the loss of bromine marked as A is more stable than the carbocation formed by the loss of bromine marked as B. So the halogen which is most reactive towards SN1 in this compound is bromine marked as A. So for A it is bromine which is marked as A. Next option B. Now iodine marked as A and iodine marked as B. If this iodine marked as A leaves as iodide ion, then there is positive charge on this carbon. This positive charge gets delocalized due to the presence of the pi bond on the adjacent carbon. So the carbocation formed if iodine marked as A leaves as iodide ion is more stable than the carbocation formed if the iodine marked as B leaves as iodide ion. So the halogen which is more reactive here is the iodine marked as A. So for option B it is iodine which is marked as A. Next C. Now here there are two bromine atoms, one which is present at the bridgehead position. This will not leave as the bromide ion. Instead, bromine marked as B will leave as bromide ion, giving stable carbocation. This is so because we can't remove bromine from bridgehead carbon. So for option C, more reactive halogen is bromine marked as B. Next, option D. In option D, bromine marked as A. This bromine, it is more reactive towards SN1 because if this carbon bromine bond breaks, then the carbocation which is formed is the tertiary carbocation, and tertiary carbocation is more stable than the secondary or primary carbocation. If this bromine which is marked as B leaves as bromide ion, then the carbocation which is formed is primary carbocation, which is less stable than the tertiary carbocation. So bromine which is more reactive towards SN1 in option D is bromine marked as A. So bromine A. So correct option out of 1, 2, 3 and 4 is option 1. For A, bromine marked as A. For B, iodine marked as A. For C, bromine marked as B. And for D, bromine marked as A. For the reaction, this is primary alkyl halide plus iodide ion forming alkyl iodide, and bromide ion is one of the products. Now, in this reaction, this is primary alkyl halide. This reaction takes place by SN2 mechanism. Now, what happens during SN2 mechanism? This primary alkyl halide, it will form a transition state where carbon bromine bond will be partially broken and carbon and iodide bond will be partially formed. So this is the intermediate formed during the reaction, and both bromine and iodine will have a partial negative charge. There will be a partial negative charge on bromine and partial negative charge on iodine. So this anion which is formed during the SN2 reaction, in this anion the negative charge is not localized on any one atom. Here the negative charge is delocalized on two atoms, that is, one is iodine and one is bromine. So since the negative charge is delocalized on two atoms, therefore this anion is less polar. This transition state is less polar. Therefore, in this question, the correct statement is statement 2. The transition state formed in the above reaction is less polar than the localized anion. Okay. So what is localized anion? Suppose only bromide ion was formed. Then here the entire negative charge is localized on bromine atom. This is a localized anion. But here in this transition state which is formed during SN2 reaction, the negative charge is delocalized on two atoms, that is, one is iodine, one is bromine. So it is less polar. So option 2 is the correct option. The correct statement regarding nucleophilic substitution reaction in a chiral alkyl halide is: first of all, what is chiral alkyl halide? Chiral carbon is carbon which is bonded to four different groups. Now let the fourth group be the halogen. So here the halogen atom is bonded to a chiral carbon. This is known as chiral alkyl halide. 1, 2, 3 are the four different groups or atoms bonded to this carbon. Now nucleophilic substitution reactions are of two types. One is SN1 and another one is SN2. SN1, in SN1 type of reaction, first of all, let this be the alkyl halide containing the chiral carbon. First of all, this carbon halogen bond breaks, resulting into the formation of a carbocation, and then a nucleophile attacks this carbocation to give the product. Now here this carbocation intermediate which is formed during the reaction. Now in this case the nucleophile can attack the carbocation or the positively charged carbon atom from both the sides, either from this side from which the halogen left or from the opposite side, resulting into a mixture of products. So two types of products will be formed. One in which the carbon atom retains the same configuration as the original reactant, that is carbon bonded to these different groups, and this is the nucleophile which attacked from the same side. So here the configuration is same, and another product that is formed is in which carbon atom has the groups on the opposite side and nucleophile has attacked from the opposite side. So a mixture of enantiomers is formed, and these both the stereoisomers, they may be formed in 1:1 ratio. So this entire SN1 reaction results in mixture of product, And since this is a mixture of the enantiomers, the process is known as racemization. So racemization occurs in SN1 reaction. And in case of SN2 reaction, what happens in SN2 reaction? Suppose this is the chiral carbon. These are the groups bonded to the carbon, and this is the halogen atom. Now in this case, from one side the halogen starts leaving, and from another side the nucleophile attacks the chiral carbon, and during this reaction an intermediate is formed. So in this intermediate which is formed, the carbon halogen bond is not completely broken, and this nucleophile and carbon bond is not completely formed. And here this is delta negative, delta negative. So negative charge is spread out, and finally this intermediate changes into product. The carbon halogen bond breaks and the carbon and the nucleophile bond forms, and the configuration of the product formed is totally different from the configuration of the reactant. So in SN2 reaction, the formation of product takes place with the inversion of configuration. So in case of SN1, racemization occurs. In case of SN2, inversion occurs. So the correct option will be option 1. Racemization occurs in SN1 reaction and inversion occurs in SN2 reaction. Hello students. Example of vinylic halide is, now four options are given. So what is vinylic carbon? Vinylic carbon is usually sp2 hybridized, and whenever the halogen atom is bonded to this sp2 hybrid carbon, then we call it vinylic halide. For example, here CH double bond CH2, and suppose a alkyl group is attached here. Then this carbon is sp2 hybridized. So this is known as vinylic carbon. This carbon is also sp2 hybridized. This is also known as vinylic carbon. Now in option 1, if we see the compound here, then this carbon here, this is sp2 hybridized, and here the halogen atom is bonded to the sp2 hybrid carbon, and it is known as vinylic halide. So example of vinylic halide is option 1. Now in case of option 2, this carbon is sp3 hybridized, so this is not vinylic. Here this carbon is also sp3 hybridized, so it is not vinylic carbon. Here the halogen atom is directly bonded to the benzene ring, so it is halobenzene and not vinylic halide. So option 1 is the correct answer. Hello students. The next question from alkyl halides. Now list of compounds is given. List 1 and list 2. We have to match the compounds in list 1 with their uses in list 2. Now iodoform. Iodoform is used as antiseptic. So A matches with 3. Then carbon tetrachloride. Carbon tetrachloride can be used as a fire extinguisher. So here B will match with the first one. CFC. CFC used as refrigerants. So compound C matches with the fourth option. And then last DDT. DDT is used as insecticide. So D2. So the correct answer is A3, B1, C4, D2. Option 3.